Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we transact your brain with weird and wonderful science. I'm Ian Woolf. On this edition, Maria Cunningham talks about first contact with aliens and time travel. But first, superconductors get hot. Room temperature superconductors at last. Researchers from the University of Rochester and the University of Nevada in the US have demonstrated a material made from hydrogen, carbon and sulfur that becomes a superconductor at 15 degrees Celsius, which is 59 degrees Fahrenheit. The catch is it needs to be at 2.5 million times atmospheric pressure to be superconducting, so it's not ready to change the world yet. Materials now used for power cables and wires, like copper, have a resistance to conducting electric current that causes them to heat up and lose power as the cables get longer. This restricts how far we can transfer power from a generator to the consumer. Superconductors have no resistance to conducting electrical current at all, so they can carry power as far as you want, from solar power generators in the desert to cities on the opposite coast with no loss. An electric current through a loop of superconducting wire can go around and around forever, becoming a way to store power. Liquid helium-cooled superconducting super-powerful magnets are used in mobile phone towers, mass spectrometers, particle accelerators, and magnetic resonance imaging scanners in hospitals. Magnetically levitated trains can go faster than regular trains for the same power because they don't lose speed to friction with tracks, just friction with the air. Superconductors also repel external magnetic fields, so that you can levitate a magnet above a superconducting track without having to use another magnet. The first metallic superconductors discovered in 1911 needed to be cooled with expensive liquid hydrogen or helium. In 1962, they became practical with the discovery of niobium titanium, which can be wound into coils without breaking to make supermagnets. Hospital scanners cost so much to run because they need liquid helium or hydrogen. This is why we're worried about running out of helium. In 1986, ceramic superconductors were developed that only needed liquid nitrogen to be cooled, which is cheap and easy to make. But the ceramic superconductors are brittle and harder to work with. They're a major component of some types of quantum computers. In December 2020, researchers crushed carbon, sulfur and hydrogen between two diamonds at a pressure of about 70% of that found at the centre of the Earth, and at a temperature of around 15 degrees Celsius. They triggered chemical reactions with laser light to form a crystal. The superconducting crystal is tiny, making it very difficult to see its internal structure and find out how it works. They don't even know at the moment the proportion of hydrogen, sulfur and carbon. They're working on it. The researchers point out that diamond needed high pressure to form naturally, but the chemical deposition techniques let you make diamonds without high pressure. Room temperature and pressure superconductors may be possible with similar techniques. Practical room temperature superconductors could replace the entire electricity transmission grid, all the lithium batteries, all of our electronics, and make supermagnets for hospital scanners, particle accelerators, and magnetic levitation trains super cheap. The paper was titled room temperature superconductivity in a carbonaceous sulfur hydride, and was published in the journal Nature. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Aliens and time travel? Maria Cunningham is a radio astronomer in the School of Physics at the University of New South Wales. I spoke to her by Zoom, where she was at home in the Blue Mountains. You can occasionally hear birds in the background. I continued the conversation by asking Maria, we have amateur optical astronomers. Do we also have amateur radio astronomers?
Yes, they're rarer beasts, and they will tend to be radio engineers who do it for their own interest. And then it merges very much into the ham radio community. And in fact, in the opening scenes of Contact, which is a wonderful movie, yes, as well as one of my favourites is as you move away from the Earth, I guess it's faster than the speed of light from the point of view of the observer. You go through all the different radio signals and you go back in time, but it also shows Ellie, the protagonist, playing with a ham radio set when she's quite younger. And so the two communities would merge into one. But I have occasionally seen radio telescopes in people's backyards. I've never quite felt like knocking on the door and asking them about it. I thought that might be a bit too intrusive. But I know Greg Reba, who was involved in the early radio astronomy, he moved to Tasmania and spent his life doing amateur radio astronomy there.
I would have thought it's such a, as you say, such a rare hobby, and they would have had to have gone to quite a bit of trouble to get the equipment and put it together, that they'd probably be happy to talk to you about it.
I think you're right. And of course, what's muddied the waters now is that I used to see a few. There was one in particular when I was catching the train from the Blue Mountains, just as you get down from the mountain to the back of a place called Emu Plains, I used to see a radio dish in someone's backyard. And I used to think, oh, I'd love to know the story of that. But then after a while, radio dishes started popping up in everyone's backyard. And of course, this was the advent of cable TV.
Yes, all the satellite dishes.
Yeah, satellite dishes. So,
they can be repurposed, can't they?
Oh, absolutely. In fact, there's something called the Allen Telescope Array, which Jill Tarter, who was basically portrayed in the movie Contact, how lucky to be a radio astronomer and get played by Jodie Foster. Yes. But she has put together a whole array of dishes, of satellite dishes, which are very cheap and off the shelf, to build a very large telescope that's quite sensitive for SETI.
Oh, wow, that's amazing. Because I'd read a few years ago about people repurposing satellite TV dishes that they don't use anymore as a SETI sort of device themselves for, I think, not SETI at home, which is the software that runs on your computer,
thing. Yeah.
But actually as their own little radio telescope to look for possible signals from space.
It's not a silly idea. The more people looking, the more likely you are to find something. My guess is it's going to be some sort of serendipity. If there is intelligent communicating civilization out there, it'll be some sort of serendipity. 2001: A Space Odyssey, of course, is the best one, where you have the monolith buried on the surface of the moon. But then that still implies someone deliberately trying to make contact. Whereas my guess is that if we find something, it will be serendipity that does it. And once or twice there have been signals that haven't been able to be explained. The more telescopes that are actually out there looking, the more chance there is of finding something. And of course, this is where science fiction is fantastic, because one of the series that I really love is the Three Body Problem.
Oh, yes.
Yes.
I've only read, I think I've only read the first book of the series. So I'm familiar with the main idea, but I haven't gone all the way through the story yet.
No, it's well worth reading, and I read it right through to the end. And after you read that, you can scratch your head. I'm not going to give the plot away, but after that, you can scratch your head and wonder about how likely communicating life is out there for some surprising reasons.
And there's a Netflix series coming up of that, I believe.
Oh, yes. I think that would be well worth watching. And of course, it starts off with some scenes from the Cultural Revolution. And I was asking my friend who's Chinese and who's actually read it in the original. She's a Cantonese speaker. I didn't ask her whether there was a Cantonese and Mandarin version, but she could obviously read either because the script's pretty much the same. But she said that I asked her if there was more censorship in the Chinese version, and she said no, they were pretty brutal about the Cultural Revolution in the Chinese version as well. So
You must be allowed.
that was
to
also
say that.
interesting.
Well, I mean, this is the idea. Most of the stories about first contact, they're not always friendly.
No, in fact, in a different context, talking about science fiction, there are many more dystopias than utopias. I don't know whether the stories are just more interesting that way, or whether we have humans have a gut feeling that aliens may not necessarily be friendly. And I think, the movie Alien and Aliens is probably not a bad indication of what a lot of people think the sort of alien life form we're going to come across will be like. Isaac Asimov had a good answer to counter this. He was saying that if a civilization who is like humans and a bit on the warlike side, to say the least, eventually they will get to the stage where they develop nuclear weapons. And if they can manage not to blow themselves up, they'll probably develop the sort of culture that won't want to go around blowing up other civilizations either. So it's a nice argument.
Well, at the moment, perhaps we're protected a little bit by the speed of light being so slow and the distances being so large.
Yes, and in fact, faster than light travel definitely seems like a hard limit in the universe. Now, there's also a saying that physics advances one funeral at a time. And if someone does manage to find faster than light travel, and there have been some hints that perhaps photons have been made to travel faster than light in laboratories. I don't quite know what to make of all those things. And so if you are coming a little bit back to science fiction, Ursula Le Guin's novels, she never had faster than light space travel, but she did have a faster than light instantaneous communication. She called it the answer ball. So she imagined, so you could communicate instantaneously, but you still couldn't travel faster than the speed of light. And that seems the most plausible scenario to me if you can find physics to send information faster than the speed of light.
But there's still paradoxes even with information going faster than light, isn't there?
Yes, there certainly are. And of course, this is where you get down into entropy. And I think there's a good argument. I haven't read it for a long time, so I can't explain it coherently, but I think there's a good argument that the short distance, the tiny particles or photons, non-localized things that you would be sending, that you wouldn't be able to get the spatial information or the time information out of them accurately enough because of Heisenberg's uncertainty principle to ever get signal back out of them. So that entropy or Heisenberg's uncertainty principle, I've seen it argued in different ways, that when you're dealing with the scale of quantum mechanics, non-localized things, etc., that no, you won't be able to send information.
Because I remember reading, and I'm really reaching back in my memory now, I think it was Timescape, where he's got physicists in a laboratory in a world that's dying from pollution and climate change.
Yes.
That finds that they can use faster than light particles to communicate with people further back in time. So they can sort of go back 50 years or something and communicate with other physicists on Earth earlier. And in doing so, they split off an alternate history because they can't save themselves, but they can put enough information to save the other Earth.
Yes. And this is a theme in science fiction that it's been done quite a few times in both books and movies. And of course, the many worlds interpretation of quantum mechanics and its interpretation, the mathematics stacks up, but there's nothing to say it's correct or incorrect.
Which is quantum physics all over, right?
Oh, yes, you're not wrong. Yes, it's the spooky side. It's interestingly enough, it's the bit I like the mathematics for the most. It's very elegant and beautiful mathematics, but relativity is much easier to write a story about than time travel. But I like those ideas, and the idea that maybe you can communicate in the past to a point before things split off. And in fact, photons, I think this was Richard Feynman's work, photons, electrons, things like that, they are not travelling in time the same way the rest of us are. So our macroscopic bodies, which are made up of so many different particles, statistically, mostly we're travelling in the same direction in time. But if you have few electrons decide to pop backwards in time, nobody's going to notice. But for individual electrons, they don't have to obey time's arrow. And from that, you can then start to wonder. You also have Bell's paradox, the idea that electrons, yes, that are separated. If the state of one flips, the other will flip as well, even though they're further away than light. That the flip happens before light can travel. It's instantaneous. And so the idea is that the distant particles have knowledge of each other.
Entanglement.
Quantum entanglement. Thank you. That's the word. Quantum entanglement. Yes. And I may have entangled my explanation.
No, that's
there
pretty
a little
good.
Bit.
That's pretty good. So it's an important thing. One of the things for me about quantum physics that makes it so fascinating is that the mathematics and the experiments that they predict have always been right. Like they've been confirmed all along the line.
Yes.
But the interpretation of what it really means for how the world works, there's multiple possible interpretations, and every new experiment doesn't rule out the different interpretations we have. So we haven't found one that's better than the others. They're different, they contradict, but they all fit the experimental data no matter what experiments we do so far.
And this absolutely fascinates me that 30 years ago, the idea of investigating Bell's paradox, it was very, very hard. Whereas now it's the sort of thing that can actually be demonstrated without too much in the way of big equipment. So we know this has been confirmed many times. I know when I'm working in our teaching laboratories, we actually have experiments that demonstrate that if you have photons going through a double slit, and if you shut off one of the slits, you end up with the pattern you'd get from photons going through a single slit. So this is back to the Young's double slit. Single slits just is quite different to the double slit. But if you have photons at such a low rate of light that only one photon goes through the slits at any time, if you've got two slits, you will still get the two slit pattern, even though each photon only goes through a single slit. So you'd actually expect two single slit patterns superimposed on each other, but no, you still get the double slit pattern. And that's fascinating that you can do that now in a second year physics laboratory with equipment that you just order by mail.
Well, in fact, I've seen there's a YouTube channel, Veritasium, with an excellent science presenter, Derek Muller, and he actually took a portable double slit experiment on the street to show people and ask them what they thought was going on and what they expected to happen and what they saw, to sort of demonstrate the physics and get them to think about it.
That great.
Oh, he's amazing.
Okay, I must look for this. It sounds brilliant.
Yes.
And okay, that is much more exciting than guerrilla astronomy. Occasionally, I think of taking a Dobsonian, a Dob, as we call them, up to my local park. Because actually I've discovered over the years, I often go out to schools and various other places, school fetes. I do a lot of school fetes, where people I know just kind of say, oh, would you bring a telescope along? And a telescope is a magnet for people, and especially for small children. Children love telescopes. And I think if I go up to my local park with my dog, half the kids in my local area will suddenly know what astronomy is. But the two slit experiment, that must really get people in.
Oh, look, he's very good. And the idea of alternate histories and multiple universes, because it got into the comics and science fiction, it's now, of course, on TV and movies, and it's become into the common ideas that people have, even if they don't normally read science fiction.
Yes, and people are learning a lot more science than they realise just by watching these movies. Sometimes it actually enthuses people to then go and do a bit of a Google search, which of course now is just the easiest thing on the planet. Back in the day, I used to have to go down to my local library.
And then find
when
the
I was
right
a child,
books.
yes, and find some books. But now you can very quickly go. I think it was Stanford University. I found when I did a quick Google an excellent description of the many worlds theory for any lay person who's interested. So if you're interested after watching the movies, but even if people don't necessarily do it then, at some stage later when they come across the science, they think back and think, oh, okay, that was just like the movie. And my discovery when having to teach science to non-science people was that you start with popular science fiction, particularly movies. I'm more of a book person than a movie person, although I love a good movie. I'm perhaps not as tolerant as I should be about gunfights in space, but I don't like movies with gunfights in Earth. It's kind of like, okay, my eyes will glaze over for the next 5 minutes while they shoot it out before we go back to the story.
Yes, or even worse if they have a fist fight in space.
Oh, a fist fight in space, yes. Yes. But the science fiction movies, the movies that everybody has seen or knows about, those are incredibly powerful for disseminating science into the community. And the universities and people who are keen to communicate science know this. And so things like the Big Bang Theory, Caltech Caltech consulted on that. Armageddon, Deep Impact, the disaster movies about the asteroids hitting the Earth, they had scientific consultants. Now, every now and then, the scientific consultants sort of get overruled because you also want an interesting movie and a good story. So some science fiction movies, I tend to regard the story as being the libretto, sort of like with an opera. You have to really suspend disbelief. But when you do that, it illustrates some concepts very, very well. And of course, you want a gripping story. You want a gripping narrative so that you want to watch.
I guess that's the two different ways you can look at science fiction films. You can use it to get across all these concepts and discuss the concepts and explore them in the film, but you can also go the other way and go, okay, so what did they get wrong, and see how much your students know.
Oh, absolutely. And I think someone was actually asking me, what's an instance of a science fiction movie getting it wrong? So the wrong thing goes into popular culture. And of course, the best one is Han Solo in the first Star Wars, talk about making somewhere in 6 parsecs. Now, of course, all of us in the know harumph and say a parsec is a measure of distance, not speed. But I think most people know that these days because it gets brought up so many times, so that even though that was used incorrectly, although the language was wonderful, I think most people you speak to would know that a parsec is a distance, not a speed.
Well, that's one of the changes from the 70s, I guess.
Yes. Obviously, they didn't have a consulting astronomer on Star Trek, although back then, I think if you'd gone down to university faculties in most universities and knocked on the door and asked for an astrophysicist to consult on a movie like that, I think they'd look down at their nose at you and sort of say, I'm an astronomer, not a Boy Scout, which someone from Caltech is actually famous for having said in a different context. When someone asked about something in the sky.
I would have thought a lot of astronomers would be science fiction fans.
They are. Actually, they are. And there's some, I guess Fred Hoyle was the most obvious one. Fred Hoyle wrote science fiction.
Yes.
As well, yes. Setting up his department in Cambridge. Now, I read The Black Cloud when I was 12 or 13, I think. Picked it up out of a box of old books that our English teacher had left at the back of the classroom. And I thought I'd never read such a fantastic book in my life.
And just quickly for the listeners, so the black cloud is about a cloud of interstellar gas that's alive.
That's alive. It's intelligent. It's disseminated intelligence. And Isaac Asimov also uses this concept in a book called Nemesis, which I'd heartily recommend. But the black cloud, I'd never come across these concepts before. I was just hooked and absolutely fascinated. But I remember going home to my father and sort of saying, oh my goodness, this is an amazing book. And my father was an English teacher, and he sort of looked at me and he said, oh yes, I think he's some sort of scientist. And if you look at the characters, you'll notice that they're all the metaphysical poets. He names his characters after metaphysical poets like John Donne, etc. And that was the end of the conversation. And so I didn't ask the obvious question, have you ever read the book? But I must say, after reading some of Fred Hoyle's stuff later, it was not high art. But for a 12-year-old, it was a great discovery in a box of books. I think I discovered The Hobbit in the same box of old books. Wow. That's the other thing. Scientists, Philip Adams once said, you can tell a lot about scientists if you look at their reading on their bedside table. You'll find Lord of the Rings, Zen and the Art of Motorcycle Maintenance, and that wonderful tome about how Princess Xena is captured from a galaxy far, far away. And I thought, yep, that's about it.
Yes. That was the second part of my interview with radio astronomer Maria Cunningham from the University of New South Wales, talking about the search for extraterrestrial intelligence and time travel. Listen next week for tales of multiple universes. You can see videos of this interview and many others on the Diffusion YouTube channel. Subscribe and like at youtube.com/c/diffusionradio. That's all from us this week on Diffusion. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @IanWoolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 MVR in Nambucca Valley, 3 MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is now narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Make a donation through paypal.me/IanWoolf or join my patrons at patreon.com/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.